Alrighty, so,
Good math.
Brant, what'd you get as a measurement to begin with?
100.
100 centimeters?
Yeah, perfectly.
And then this was 50?
Yep.
And then this was 25?
Yep.
And then this was what?
12 and a half.
Then this was what, 6.25? 6 and a quarter?
Yep.
And then this was
125. Or an eighth.
3.125,
Yep.
an eighth of a centimeter. And then this was 1 point,
I didn't get the decimal. I just got 9/16. 1 and 9/16. Or 20,
Centimeters.
20. Yeah.
25 sixteenths
Yeah.
centimeters.
Uh-huh.
And then this would be 25 32nd centimeters.
Yep.
And then you graphed it.
Not yet.
So what? You said we'll make this 100. Does that work? And so then this would be halfway. And then this would be halfway. So do they get connected? What'd you have for an equation? Anybody have an equation?
X to the 1/2.
Well, okay, then if I put 0 in there, I should get 100.
No, opposite of that. Sorry. Like,
100,
would be like
100 what? Two? Want me a 2 here as a base? Two. So now I got 200. I can only have 100.
I think it's 2
Does it have an exponent? What is the exponent? Negative x. So if I put a 1 in here, it'd be 50. If I put a 0 in there, it'd be 100. If I put a 2 in there, it'd be 100 divided by 4. Does that sound right?
Yeah.
Yep.
Everybody agree with that? Okay. Is this example of growth or decay? Okay. So, back in, I don't know why I have paper folding there. Does everybody have this on the back?
Yeah.
Okay, that's me screwing up. All right, so we also know it should be able to be written this way. C e to the kx, but this time k is going to be less than 0, correct?
Yeah.
So it's going to be, do we know c?
100.
So when we had 1, it was 50, correct? Would everybody agree with that? So I get a half equals e to the k. So what's k equal to? ln of 1/2, right? So this is the same as f of x equals equal to 100 e the ln of 1/2 times x. Well, this has got to be negative. Isn't this the same as this? Am I right? So isn't this the negative ln of 2?
Wow.
Am I right on that?
Yeah.
So I can write this as 100 e to the negative ln of 2 times x, or negative 0.693, approximately, correct?
Yeah.
Is that making sense to everybody? And then I could do the steps like I did before. I could bring the x up here, or even the negative x up here, and I'd get 2 there, correct? I'll just do it. In other words, I can say this, the ln of 2 raised to the negative x power. And then this is going to be 100. There's my inverse functions times 2 to the negative x. Everybody okay on how I transition there? So if I triple something or made it a third, then you'd have the ln of 3. Okay, if it, like in decibels, they go by powers of 10. Okay, so I'd have the ln of 10, or 10 to that power. Okay, is that making sense to everybody? Okay. Transition to some other notes, and then I'll give you that assignment.
I'm guessing it's gonna be.
We are about to, for breadsticks, we do for breadsticks,
What are people in
hot
school
fish
supposed to
and,
do if they like wanna go into a career? Like we have barely any like medical
Yeah, you
classes,
are right.
we don't have any like health field classes.
we're really beautiful.
We apparently barely have the math classes now. What are they supposed to do? Everyone just does business?
Well, cause you know the Higgs scope here, so they have a lot of.
Oh, I know, but we
But
should
I
also
just-
still have math classes.
It's like I feel like there should be.
It's like important.
I know,
It's not
like, and this is
it's
like
not
basic
everybody
math
doesn't wanna
too.
teach it. It's
Teach
so
what?
many. BC,
What?
Calc BC.
What about coverage?
We're saying that you would like be willing to teach the class, obviously, so
Even if
why
there's
would
like
you,
only
take it
2
away?
people in
Yeah.
that.
Yeah, it would.
Yeah.
I'd even teach a class if nobody was in there.
Yeah, I come to work and just lecture to an empty room.
Do basketball all by myself.
Alrighty,
Make a YouTube channel.
so we're gonna connect these with differential equations, okay? I gotta grab one thing here. Let me get to this pile. Alrighty,
What we do? I don't like it.
They're making like a
So-
half careers, but we can't take it, so I think it's next year.
this right here is your y-intercept.
It's a lot of years leaving school lunch.
This is your base. It's also your growth or decay factor. So let's say I have something like this. This is also the initial value. I've decided not to know how to spell anymore. So I am going to have dy over dt. So I'm going to take the derivative here, and this is going to be equal to, if you remember, a is your constant. So I'm going to have the natural log of b times b to the t power. In other words, if you remember this, you probably forgot, 2 to the x power its derivative, dy dx, is equal to the ln of 2 times 2 to the x. Do you remember that derivative?
Yeah.
Okay. You don't? Okay, I'll even show you why. So I can come here and I can take the natural log of both sides, and I get x times the natural log of 2. If I take the natural log of both sides, you okay with that? The derivative of this is 1 over y dy dx. This is a constant. The derivative of that is 1, so I get the ln of 2, correct? So now if I multiply both sides by y, I get dy over dx is equal to the natural log of 2 times y, but what's y? 2 to the x. Well, that was really fast, but is it making sense? Okay. So then what I can do is, I said, this thing right here, this product, notice that I can rewrite it like this. I'm just looking at my notes here. This right here is y, isn't it? So I can say dy dt is equal to y times the natural log of b. And this natural log of b I define as k, so dy over dt, the differential equation is in the form of k times y. So whenever you see this, you know you're going to have this differential equation is going to create an exponential function. Here's an example. Okay, I'm going to just set them up. The weight of an animal is increasing at a rate proportional to its weight. So I'm increasing, so I have a rate, dw dt, and it's proportional. So I got my k value times my weight. Right here I have a bacteria population is shrinking at a rate proportional, so I have a rate, so I have dp over dt, it's proportional to the population size. So this will be an exponential function, this will be an exponential function. I'm going to solve this using separation of variables. This is kind of what we just did a little while ago. I'm going to have 1 over y dy is equal to k dt. I'm going to integrate both sides. I'm going to get the natural log of the absolute value of y. Over here I'm going to have kt plus c. Remember, k is a constant. That means y is equal to c e to the kt power. And this k is equal to the natural log of some base. Like when we doubled, k was equal to the natural log of 2. When we were using a half, k was equal to the natural log of 1/2, or the negative natural log of 2. Does everybody see that connection? And so, if you see this, you automatically, this differential equation will automatically give us this exponential function. So you see these, like this one right here. This one will be y equals c e to the 6t power. Think about that. I'll have 1 over y on this side. I'll have 6 dt on the right side. when I integrate, I'll have 6t plus c. So right here it says y is equal to 5 when t equals 0. So my equation must be 5e to the 6t power. This is going to be y is equal to c e to the negative 3t power, but I'm told this initial condition, so I know c, it is 4e to the negative 3t power.
Why don't we use x for this one? It says dy over dx, not dy over dt, so.
Oh, it should be x here. I didn't see the x. So it should be an x. I'm so used to time. It says an animal weighs 3 pounds at birth, so C is equal to 3. 4 pounds just 3 months later. So I'm going to have the weight is equal to C E to the KT power. So the weight is equal to 3E to the KT power. I'm told that in 3 months it's now 4 pounds. So 4 equals 3E to the K times 3. Which means I have the ln of 4/3 is equal to 3k. So I have 1/3 ln of 4/3 is equal to k. And that was approximately 0.096 was k. So that means my weight is equal to 3e to the 0.096 t, and in how many months does it ask? 5 months. 3e to the 0.096 times 5 gave me approximately 4.846 pounds.